You're sitting at your desk. Your phone buzzes. It's just an email from your boss. But your heart is already racing. Your palms are sweating. Your stomach tightens. For a moment, your body is certain something terrible is happening. But the real answer is far stranger. Your body isn't reacting to an email, it's reacting to a lion. Not a real one. Not today. But somewhere in your nervous system, a very old alarm just went off, and it doesn't know the difference between a predator and a Slack notification. Your brain was built for a world that no longer exists. 200,000 years of human history happened on the savanna, in small bands, surrounded by real physical danger. Your ancestors who survived were the ones whose bodies reacted instantly to threat. Fast heartbeat, tunnel vision, a flood of energy to the legs. Think first, and your dinner. React first, and you live to pass on your genes. That reaction didn't disappear when danger did. It's still running, right now, in you. In the 1920s, a physiologist named Walter Cannon gave this reaction a name that's now famous: fight or flight. He noticed that under threat, the body released a surge of adrenaline, redirecting blood away from digestion and toward muscle. The body was preparing for one of two things: attack or escape. There was no third option in Cannon's model, just power, aimed outward or aimed at running. But here's the strange part. Your body still builds that same surge for things that are not lions at all. A late reply from a friend, a red notification badge, a meeting invite with no agenda. None of these can actually hurt you. Yet your amygdala, the almond-shaped alarm center buried deep in your brain, cannot tell the difference between a predator's shadow and a passive-aggressive text message. Why would evolution leave such an obvious flaw in the system? It didn't actually. It's not a flaw. It's a shortcut. Neuroscientist Joseph LeDoux spent decades mapping how fear moves through the brain, and he found something remarkable. There are two paths a threat signal can take. One is slow, moving through the cortex, where you consciously evaluate whether something is actually dangerous. The other is fast, a direct line from your senses straight to the amygdala, skipping conscious thought entirely. That fast path exists for one reason. Speed saves lives when the threat is real, but it also means your body sometimes sounds the alarm before your mind gets a vote. This is why you can feel your pulse spike from a stranger's tone of voice before you've even processed their words. This is why an unexpected knock at the door can make your chest tighten for half a second, even in a perfectly safe home. The ancient system fires first. The modern brain explains itself later. Now here's where it gets more interesting. Ancient threats were almost always short. A lion appears. You run, or you fight, or it passes. Within minutes, one way or another, it's over. Your stress hormones spike, then drain back down. Your body returns to baseline. Modern stress doesn't behave like that. Stanford neuroscientist Robert Sapolsky has spent much of his career studying exactly this mismatch. His research on primates and humans shows that chronic, low-grade psychological stress, the kind with no clear beginning or end, keeps the body's alarm system switched on for days, weeks, sometimes years. An overdue bill, a tense relationship, an uncertain job. None of these are lions, but your body treats them like a lion that never leaves. And a body built to sprint away from danger was never designed to remain on high alert indefinitely. Sapolsky's work found that prolonged activation of this stress system is linked to elevated blood pressure, disrupted sleep, suppressed immune function, and long-term changes in the very brain regions responsible for regulating fear itself. The alarm meant to save your life for 5 minutes was never meant to run for 5 years. Think about that for a moment. The system that kept your ancestors alive on the savanna may now be quietly wearing down the body of someone who has never even seen a wild predator. There's another piece to this. It isn't just danger that triggers the ancient alarm. It's uncertainty. Psychologist Robert Sapolsky and others have pointed out that unpredictability itself is deeply destabilizing to the nervous system. A lion you can see and predict is frightening but manageable. A lion that might be hiding anywhere, that you can never quite locate, is far worse. Modern life is full of lions you can never quite locate. An ambiguous text message, a boss who might be upset or might not be, a future that feels uncertain in a dozen small ways at once. Your amygdala doesn't require a visible threat to activate. It only requires the possibility of one. This is also why waiting is often more exhausting than the bad news itself. The moment you finally learn the outcome, good or bad, your body can finally stand down. It's not the danger that drains you the most. It's the not knowing. So what do you do with a body that's still bracing for a predator that vanished thousands of years ago? You can't rewire 200,000 years of evolution in an afternoon, but understanding the mismatch changes something important. It changes the story you tell yourself about your own reactions. When your heart pounds before a presentation, that isn't weakness. It's an ancient survival circuit doing exactly what it was built to do, just aimed at the wrong target. When you feel a flash of dread from a vague message, that isn't irrational. It's your amygdala treating uncertainty the way it once treated a rustling in the grass. Researchers studying stress recovery have found that simply naming what's happening in the body, recognizing it as an old alarm rather than genuine present danger, can begin to shorten how long that alarm stays active. You cannot delete the system, but you can stop mistaking it for truth. Because that's really what this comes down to. Your body is not lying to you. It's just reporting from a world that no longer exists. Somewhere inside you, a very old alarm is still scanning the horizon for lions. It doesn't know that the savanna is gone. It doesn't know that most of what threatens you now cannot actually touch your body at all. Tonight, when your phone buzzes and your stomach tightens before you've even read the message, you'll know the truth. It isn't your boss. It isn't the email. It's a lion that's been extinct for longer than language has existed, still running through your blood, still asking you to run.